Hi everybody, happy Tuesday. So I'm throwing this video out there on the same day as our polynomials unit test, which is really just a summative assignment. And this is a totally optional video. So I just wanted to go into it. It's in the workbook. And what this is actually is where does factoring go when I get to the 20 level? So when you get to 20-1 or 20-2, what are you going to do with factoring? And really, what is the whole point of learning how to factor? So totally optional video. Watch it if you want, don't watch it. You can save this for, a weekend. You can save this for when you have a little bit extra time. But I just wanted to throw it out there for those that are curious and those that want a little bit extra. So with that said, let's jump right in. All right, so we're on page 377, and we're going to look at a factoring extension. And this is really where it goes in 20-1. So the whole point of factoring is actually so that we can solve quadratic equations. So at the grade 9 level, you know how to solve linear equations, right? Like 3x plus 5 equals 7, or x plus 1 equals 5, or whatever, something like that. I can solve linear equations. But as soon as I have an x squared, well, we really don't know how to solve that. And we don't actually do that in the 10 level, but you do it in the 20 level. And factoring is going to be a huge asset in allowing us to do that. So we're going to take a look at these examples and kind of build to the idea of factoring. So it says, x minus 3 equals 0. That is only true. Well, I could solve that, and maybe I'd show a little bit of work. I'd say, I could add 3 to both sides, and you'd get an answer of x equals 3. That's a little algebra. So that statement, I can make the left side equal to 0 if x is 3. That's the value that makes the answer 0, or makes me equal the right side. X plus 1 equals 0. I could do something really similar. I'll write it over on the side. Subtract 1 from both sides. Balance it out. You get x is equal to 1. Okay, great. So I can solve a linear equation. Well, the next one is kind of an interesting idea. X minus 1 times x plus 3 is equal to 0. Well, there's actually two cases that make that 0. And I want to dive into that a little bit deeper. So I'm going to open up a new tab here. Okay, so I've got those that equation up in a new tab here, x minus 3 times x plus 1 equals 0. Well, the interesting to look at is that's actually a product. It's this bracket times this bracket equals 0. And if I'm trying to get a product equal to 0, that's maybe one of the easiest things I can possibly do, because I know something times 0 gives me a product of 0. So what I have to look at is I have two things that are multiplied, this bracket and this bracket. And if either of those brackets were to equal 0, it would multiply and give me that right side of 0. Which means if x minus 3 were to equal to 0, it doesn't matter what x plus 1 is, because anything times 0 is still 0. And I actually already solved that. We did that on the other page. We said, hey, what if x minus 3 were equal to 0? Well, that happens when x is equal to 3. Meaning, if I plug in a value of 3 to this, you get 0 times 4. Well, it equals 0. It doesn't matter that that is equal to 4. That could be anything, because 0 times anything is still 0. Or the other thing I want you to look at is, well, what if this part were equal to 0? Which we already solved as well. It was x equals negative 1. Okay. I solved that wrong on the first page. Let me correct that. Sorry, that's supposed to be a negative 1. Well, that would be an opportunity where the whole thing equals 0. So when I'm looking at this, what I really want to emphasize is there's actually two solutions, right? If I were to plug in x equals negative 1, you'd get 0 times negative 4. And it doesn't matter what this is. 0 times anything is still 0. So if I can separate it into a product, or separate it into its factors, I can solve when each of them are 0 and find the solution. Okay, let's jump back to the other one. Okay, so I have the answers. It was x is equal to 3 and x is equal to negative 1. Okay, well, the one below 4 times x minus 3 times x plus 1, I'll quickly add that 4 over here. So really all you're saying is multiply by 4. Well, that actually doesn't change anything, because in the first example, if this is 0, 4 times 0 is still 0, times whatever, still 0. The fact that I already have a 0 in there means I'm good. So it doesn't matter what I'm multiplying by. as long as one of the factors is equal to 0. And same thing, if x plus 1 were equal to 0 in the second scenario, it'd be 0 times whatever, still gives me my answer of 0. So it's actually the same answers for that one. X is equal to 3, or x is equal to -1. So when I'm solving these quadratics, I might actually get 2 answers instead of just 1 answer. Okay, and that's really it. Okay, it goes through, kind of explains what I just explained, so let's skip that and let's try a couple examples. So, complete the solution to the equation x squared minus 9x plus 20 equals 0. The way that currently looks, I have no idea what x value I could plug in on the left to give me an answer of 0. Okay, I have no clue. But I know I could factor it, and if it maybe looked like a product, I could absolutely solve for 0. So that's what I'm going to do. Factoring this thing, it would multiply to 20, add to -9. I'll do this quickly. Those numbers would be multiply to 20, add to -9, -4, and -5. So you'd have x minus 4 times x minus 5 equals 0. And what we just looked at is, hey, if this little thing were equal to 0, this first bracket, the whole thing multiplies to 0. Or if the second bracket were equal to 0, the whole thing would multiply to 0. So I solve each of those separately. If x minus 4 is equal to 0, I'll show my work down below. I would add 4 to both sides. Oh, x equals 4. Or the other bracket, if x minus 5 is equal to 0, add 5 to both sides. You get an answer of x equals 5. Well, there you go. Those are the 2 solutions that solve this quadratic. Those are the 2 x values that satisfy this. X equals 4, x equals 5. And sometimes we can just write our solution as 4, 5, meaning 4 and 5. Okay, there you go. That's solving a quadratic. Let's move on. Alrighty, x squared minus 81 is equal to 0. Okay, I want to do this one 2 ways, and then I'll talk about it. So the first way, I'm actually just going to open a new tab to look at. Okay, x squared minus 81. If you looked at this, you might actually see a different way to solve, and I want to talk about it and maybe talk our way through. I might just say, hey, why don't I add 81 to both sides and just do some algebra? And then you get x squared equals 81. And then, hey, I know how to get rid of the squared. I take the square root of both sides. Okay, so x is equal to 9. Well, I want to kind of pause there so we can remember the actual definition of a square root and kind of this idea of if x squared is equal 81, that's really saying what times what equals 81, or what times itself. And what we maybe remember from last unit is there's actually 2 options there. Because the obvious one, yeah, 9 times 9 is equal to 81, or 9 squared equals 81. But -9 times -9 also equals 81. So my answer, and this is something a little awkward, if I ever introduce my own square root, and this is now taking it to a new level, if I introduce my own square root, I need to realize that it could be the positive or it could be the negative version. So there's actually 2 answers. Well, that's a little confusing, so I'm going to show you an easier way to make sure we get both answers. Okay, let's take a look at that. Okay, so we're back in the workbook. If I look at that, the method we just outlined was, hey, factor this thing so that you can write it as a product. And yeah, that's a difference of squares. That would just be x minus 9 times x plus 9 is equal to 0. And then from there, I can solve both of the brackets. If this first bracket equals 0, multiplied by whatever is still going to equal 0. Or if the second one, if I solve this for 0, multiplied by whatever still equals 0. Okay, well, the first one, that equals 0. I add 9 to both sides. That happens when x equals 9. The other one, if x plus 9 equals 0, I subtract 9 from both sides, and x equals -9. Hey, there you go. X equals 9 or -9. And I solved it. Okay, so Just keeping in mind the two solutions. So I think it's easier to do by factoring and then solving. All right, let's try the next one. 4x squared minus 9. Oh, that's another difference of squares. You'd get 2x minus 3 times 2x plus 3 is equal to 0. And I'm going to solve both of the brackets. A little bit harder because I actually have to do 2 steps. I would add 3 to both sides, 2x equals 3. And then I divide by 2 and I get a fraction, x equals 3 halves. Or the other bracket, the 2x plus 3 could equal 0. So 2x equals negative 3, or x equals negative 3 over 2. So I again have 2 solutions, 3 halves or negative 3 halves. Okay, solving by factoring. Okay, one more. See if I can squeeze this one in. 10x squared minus 90x. Well, that's not actually a difference of squares, but I have a common factor. I could factor out a 10x, and you get left with x minus 9. And here there are still 2 instances where I could get a 0. If I just plugged in x is 0, 10 times 0 is 0, times whatever I get in the bracket, still 0. So that one I really don't have to solve. I can just say, hey, x is equal to 0. And then from the bracket, if that bracket were equal to 0, or if x were equal to 9, you'd get 0 times whatever, so still equals 0. Oops, I wrote a 3 instead of 0. So x equals 0 or 9. Okay, and I kind of ran out of room. I don't have room for the last one, but I'd say, hey, maybe factor out a common factor, maybe do a difference of squares. You could try that one ahead of me. Okay, let's move on to a couple of questions below. Okay, 3x squared minus 13x minus 10. Well, if I'm going to factor that, I'm going to have to use decomp, I think, which is okay because I know how to do decomp and I can figure out what my factored is going to be. So multiply to negative 30, add to negative 13. Those numbers are negative 3, let me think. Negative 15 and 2. Great, so I do decomp. 3x squared minus 15x plus 2x minus 10. I factor by grouping, bringing out the first 2 terms. Take out a 3x. Next 2 terms I can bring out a 2. I'm doing this pretty quickly because I don't want you to worry about the factoring. I want you to worry about the other part. And I get x minus 5 times 3x plus 2. Okay, so that's my factored version. Oops, and the whole time I should have been saying equal to 0, equal to 0, equal to 0, because I'm actually trying to solve now, not just factor. Well, solve the first bracket. That happens when x is equal to 5. There's one answer. And solve the second bracket, which is a little bit harder. 3x plus 2 equals 0. Well, subtract 2, so 3x equals negative 2. And I get a fraction again. X equals negative 2/3. But it's all good. I get my 2 answers, 5 or negative 2/3. Those are both solutions to this quadratic. Okay, B, 5x squared plus 30x equals negative 25. Well, everything I've done is solving for equal to 0. And so that's how I need to set up my question. So this one is not the proper way right now. Oops. I need to start this question by rewriting it. And I would say, hey, I could add 25 to both sides. And I would get an equation equal to 0. And now I can solve using factoring. It has to be set up equal to 0. That's one of the things I look at. Okay. Well, if I'm going to factor this, bring out the common factor of 5. X squared plus 6x plus 5 equals 0. And now I factor the part in the middle, x plus 5, x plus 1. Great. So now I have 3 things that are multiplied. The 5 times the first factor times the second factor. Well, if this bracket or this bracket equals 0, I'm good. So I can do that quickly. X plus 5 equals 0. Solving that, I get x equals negative 5. Or the x plus 1 could equal 0. Solving that, you get x equals negative 1. So again, I have 2 solutions. x could equal -5, or x could equal -1. And there you go. That's solving a quadratic equation using factoring. Okay, the last thing we're going to look at, solving maybe a problem using this. So here's the system. It says introduce a variable to represent an unknown value. Okay, so this is where I'm trying to solve for something specific, and I need to give it a variable. I'll usually pick x. Okay. Or length, or like L or W, whatever letter fits. Form an equation using the polynomial. Okay. And then solve using the methods. And then at the very end, I'll state my answer. Okay. So let's go down and try this question that it gives us. It says the area of a rectangular sheet of paper is 300 centimeters squared. The length is 5 centimeters more than the width. Form a polynomial expression and solve it to determine the perimeter of the rectangular sheet. Well, whenever I get a problem that allows me to draw a picture, I do that. So it says it's a rectangle, and it tells me the area is 300 centimeters squared. Okay. And then in terms of picking variables, I said I always pick x. Well, this is like a rectangle. I'm going to talk about length and width, or L and W. The length is 5 centimeters more than the width. So that kind of means, well, hey, if you had the width, the length is, or the length equals 5 more than that. So width plus 5. So what that does is it allows me to talk about the width, and then the length I could just call W plus 5. So stating my variables and setting this up. And this is something we spent a lot of time working on in 20. Okay, so now that I have this, I need some sort of equation. And I'm thinking, well, I have, length and width, or at least I can refer to the length and width. And I have the area. And what I remember is area is the length times the width. Or in this case, the length is W plus 5. The width, we're just calling the width. And the area is 300. So I can plug in my values, and all of a sudden I have an equality. I have numbers and variables, and I have that equal sign. Okay, well, let's clean that up a little bit. I'd do the distributive property. W squared plus 5W equals 300. And then you'd say, ultimately, I want to solve this thing. Well, I have to set it equal to 0. So I move that 300 over. I subtract 300 from both sides. And now I have a quadratic set up in a way that I can solve it. I would factor that thing by inspection. Multiply. Oh my goodness, this is a big one. Multiply to -300. Add to 5. Multiply to -300. Oh my goodness. Well, those numbers is a big one. I believe 20 times -15. That gives me -300. Add 7. Perfect. Okay, so W plus 20, 20, W minus 15. And now I can solve. If W plus 20 equals 0, I get a solution. Well, that happens when W equals -20. Or when W minus 15 is equal to 0, I get a solution. Or when W is equal to 15. So I have two solutions to what is the width of this rectangle, or this rectangular sheet. And I'm just going to pause and I'm going to think about it well, we're talking about width. And I might be a little confused because I have two answers. Well, if I'm talking about the width of a rectangle, this is a physical object. The width can't possibly be -20. So that's a false solution. I can't have a negative width because it's a length, right? It's a measurement. I can't have a negative width. So it solves the equation, but because of the context, it doesn't represent the context properly. So there is my solution. Width is equal to 15. Just the one in this case. In terms of solving the quadratic, you have two solutions, but in terms of the context, you only have one. Great. Well, there's my width. The length, I know, is 5 more than that. Length equals W plus 5. Well, that would be 20. I can do that in my head. I would probably show some work, but I'll do it in my head. Okay. This question actually asked for perimeter. So now I know I have length of 20, width of 15, length of 20, width of 15. Perimeter, okay, would equal, oh, I ran out of space. The length plus the width plus the length plus the width. Perimeter is just add them all up. 20 plus 15 plus 20 plus 15 equals 70. And I think my unit was centimeters. Okay, there you go. The final thing I actually do, if it's a word problem, I would normally make a statement, but I ran out of room, so I won't do that. But I would normally say, hey, perimeter equals 70 centimeters. And there you go. So complicated question, something we spend a lot of time in at the 20 level, but it's interesting to look at. Okay, we're not going to do question 5. And if you wanted some practice, right? This is an optional lesson, so obviously optional practice. The homework for this lesson, you could do questions 1 and 2, but really no expectations on it. It's just for your personal interest. So there you go. All right, so there it is. Just an extension. Hey, why are we factoring? A little bit of extra information. So if you wanted to try the practice questions, go ahead. Other than that, no worries. Hopefully you did well on the assignment today, and we are moving on to a new unit tomorrow. So hopefully you got a little bit out of that. Might not have made 100% sense. That's something you'd spend almost a whole unit on at the 20 level. I just wanted to give you that little sneak peek to pique your interest. So as always, thanks for watching. Smash like button, subscribe, all of that, and I'll check in with you guys tomorrow.